All right, IM1 students. So this week we are studying systems of linear equations. And this is a big idea. I want you to learn at a very high level. So we're taking our time here to really understand the concept. So the first question for you today is, can you explain to me what is a system of linear equations? Try not to go back to your notes if you can. Okay, I'm hoping you told me something about a system of linear equation being two or more linear equations. An example here is on the upper right graph here, we have a red line and a blue line. That represents a system of linear equations. My next question for you is, can you explain how you find the solution to a system of linear equations given the graph of two lines? All right, I hope you told me the answer is it's the point of intersection between the two lines. So this point here would represent the solution. We write that as an ordered pair, x comma y, so 7 comma 11, or this one looks like maybe it's 2 comma 3. Whatever the point of intersection is, I want that as an ordered pair. That's your solution for a system. So with that in mind, here's the system. We have the equation negative 3x plus y equals 2. That's this gold line. We have the equation x plus y equals 6. That's this blue line. So I want you to tell me, what is the solution of this system of equations? All right, I hope you gave me the answer 1 comma 5. That's this point of intersection. X is 1, y is 5. Now, what's so special about that point? Well, if you think of the gold line, there's a plethora of points on that gold line, right? Point, all over the place. Look at this blue line. There's a plethora of points that are on that line. Point. So there's lots of different x and y values that we could substitute into this equation that would make it true. That's what a line is. But what's special about our one point of intersection? That is the one point, that x and y combination that will make this equation true, negative 3x plus y equals 2, make that a true situation. And it will also, at the same time, make x plus y equals 6 be true. So that's the only point that is a solution for both linear equations. All right, let's look at this example. We have the red line and the blue line. In this case, these are special types of lines. They're called parallel lines. They have the exact same slope value. The slope value is negative 2, and they have different y-intercepts. Like the blue line, the y-intercept is about 0.3, and for the red line, it looks like it's about 0, negative 3, right? If I read that correctly. All right, so they have different y-intercepts, but they have the same slope value. Can you tell me what is the solution for this type of system of equations? All right, I hope you came up with no solution, right? These lines go on and on forever. They're infinite. They go both directions, infinite forever. Can't talk this morning. But they will never cross. They will never intersect. Therefore, there's no solution when you have a system of equations and the lines are parallel. All right, now let's look at another special case. In this case, we have the blue line, and they try to show you here the red line is on top of the blue line. So in this case, both lines have the exact same slope value, the same constant rate of change. They also have the exact same y-intercept. So this is a situation that makes it so they're not parallel lines. They're basically the same line, maybe a different equation for each line, but the equation represents the exact same line. So can you tell me, what is the solution for this special situation, for this system of equations? What is our solution? All right, I hope you said infinite solutions, right? Because no matter where I go on the blue line, point, it shares, the red line also has that point. It intersects there, right? Every point intersects with each other. So in this case, it is an infinite number of solutions. All right, I'd like to check your understanding now of solving systems by actually graphing them in Desmos. So if I go in the Desmos, I want you to remember, I could type in an equation. So here I typed in y equals negative 3x minus 3. That's going to be my red line. I also typed in a line now in standard form, 2x plus 5y equals 20. So that's my blue line. So my blue line, I have it in there in standard form. My red line is in slope-intercept form. So then all you do in Desmos is you got to find where the points of intersection is. So you got to go on your graph and you got to find the point of intersection. If you just click on it in Desmos, it tells you that point value. So this point is negative 2.692, comma, 5.077. Yes, the point of intersection is not always a pretty whole number or a pretty integer, right? Sometimes you're going to have these ugly numbers because that's where they intersect at. That's the point of intersection that they have in common. And so with Desmos, it makes it real easy to get the precise answer. You can imagine if we graphed this by hand, we would be able to get kind of a ballpark estimate, but we would not get this precise answer that we get with Desmos. So now I'm going to give you a number of these that I want you to go ahead and graph them yourself on Desmos on your Chromebook, and then you're going to give me the answer here in EdPuzzle. All right, so let's look at our first example. I want you to graph. I'd like you to do this one. Y equals negative 1/6x minus 3, and y equals 1/2 x plus 1. Go ahead and graph that in Desmos right now and give me the answer. All right, let's go into Desmos and take a look. So I graphed each line. So my red line is y equals negative 1/6x minus 3. So the line's decreasing, crosses here. The y-intercept is 0, negative 3. My green line is the y equals 1/2 x plus 1. So y-intercept is 0, 1. The slope is positive 1/2, so it's increasing. So then I clicked on the point of intersection there, and you can see that the answer is negative 6, comma, negative 2. That's our solution for both of these equations. If I substitute x is negative 6, I should get y is negative 2. Let's try it. Negative 1/6 times negative 6 is positive 1. 1 minus 3, negative 2. Works. Let's try it here. 1/2 times negative 6, well, that's negative 3. Negative 3 plus 1, negative 2. It works for both equations. All right, let's try another one. How about this? Y equals negative x minus 5, and y equals 3x plus 3. Try that one. All right, so I graphed those two lines in Desmos. My red line is y equals negative x minus 5, so that's a negative 1 slope. It crosses at 0, negative 5. My green line is y equals 3x plus 3, so that line's increasing. It crosses at 0, 3, and the slope is 3. So what's the answer? I click on the point of intersection, and my answer is negative 2, comma, negative 3. All right, let's try another one. Ooh, tricky one here. Y equals 6x plus 3. Y equals negative 9. And I want you to think to yourself, before you graph this in Desmos, what does the line y equals negative 9 look like? All right, so did you predict that your line would be a horizontal line? Y equals negative 9 is a line that has its y-intercept go through 0, negative 9. But every point on there, the y value is negative 9. X may change, but the y value is negative 9. On a red line, y equals 6x plus 3. It crosses at 0, 3 is the y-intercept. The slope is really steep because it's 6. And so then our point of intersection is this point right here. Negative 2, comma, negative 9 is our point of intersection for that one. All right, how you doing with this so far? Hopefully you're doing well. Let's take a look at another one here. Number 4, y equals 1/3 x minus 1, and y equals negative 2/3 x plus 8. Again, let's make some predictions. Think to yourself, is this line going to be increasing or decreasing? Is it going to be steep or relatively flat? Same thing with this line, y equals negative 2/3 x plus 8. Is it increasing or decreasing? Is it steep or is it relatively flat? Go ahead and graph them in Desmos and give me the answer to this system. All right, did your predictions come true with the lines? And then did you get the point of intersection to be negative 27, comma, negative 10? That's our solution to this system. All right, we are on a roll. Let's try this one. y equals negative 5/7 x minus 9, and then y equals 10/7x plus 6. Predict what those lines are going to look like, and then let's find the solution for this system of equations. All right, it looks like our solution for this system, you should have got -7, -4. So again, the red line, negative slope, you see it's decreasing. The purple line is the 10/7, so that's a little bit bigger than 1, so it is increasing. It gives you the y-intercept, so there's the 0, 6, you can see that. The y-intercept on the red line was 0, -9, you can see that point there on the graph. But again, our answer to the system is -7, -4. Let's try one more, and I'm going to throw a little bit of a curveball at you on this one. So do you remember these lines? So we already saw one earlier with y equals, so y equals 13. But now I'm also going to give you the equation x equals -5. What does this line look like on top, y equals 13? What does the x equals -5 look like? And then find the solution for this system for me. All right, how were you with your predictions? So the line y equals 13, that is just a horizontal line. And that makes sense. If you think about y equals mx plus b, what's the slope of a horizontal line? That's right, it's 0. Okay, so y equals 0x plus 13, because there's our y-intercept. That would be the equation, but we don't need to write 0x, because 0 times any number is always going to be 0. So that's why it's just y equals 13. Now the vertical line is just x equals -5, because no matter where I go on this line, you see how x is -5? See how the y value changes as I go up and down this line? That's sweet, isn't it? Look at that. So you see how the y value changes, but the x always is -5. That's why that equation is x equals -5. So then what's our point of intersection? Simply -5, 13. All right, let's do some closure here. Your closure question. I would like you to make up your own systems of linear equations that has one solution. I want you to give me that equation, and I would like you to give me what the solution is for your ordered pair for that system that you make up. Let's get creative here. Why don't you do one in slope-intercept form, and why don't you do the other one either in point-slope form or standard form? Surprise me. All right? That's your closure, and that wraps up today's lesson. Good job, IM1ers.